In section 1, we learn about equations and how to balance them. Balancing equations should not be something new to you if you took 9th grade physical science. I know that the 9th grade physical science teachers at Marion spent some time going over this. After working out several problems, it should be something that's rather quick and easy for you to pick up on. When we balance equation, we're taking a tally of how many atoms of each element we have on the left side, the reactant side, and making sure that it's equal to the number of atoms of each element that we have on the product side, or the right side of the arrow. The only thing that we can do when balancing a reaction is we can write numbers in front of each element. So where I've drawn these red lines, we can write in numbers. They have to be whole numbers. These whole numbers distribute out to every element that's listed afterwards. One thing that some students do that is helpful, we make a list of all the elements that are in our reaction, and we can total the number that we have on each side. This is not something that's necessary for you to do, but it can be helpful. All right, so to begin, on the left side, we have F2, so we have 2 atoms of fluorine. So we'll put a 2 here. We have 1 sodium and 1 chlorine. And then on the right side, if we look, we have 1 sodium, we have 1 fluorine, and 2 chlorine. So this equation is not balanced. We have 2 fluorine on the left. We need to put, on the right-hand side, we need to put a 2 in front of NaF. This 2 will distribute out to Na and also to F. So now we can change this number to 2. It also changes our number of sodium. So now Na also becomes 2. So our fluorine's done, it's balanced. Now sodium. We have 1 on the left and we have 2 on the right. So we need to go back and put a 2 now on the reactant side. So this becomes a 2. So our sodium is now balanced. And then if we look, the 2 on the reactant side, not only did it go to Na, but it also goes to Cl. So and then on the right side, on the product side, we also have 2 chlorine. So now chlorine is balanced. We do not write in ones. Ones are always understood. So now we have a balanced reaction. Let's look at another sample problem. We have potassium plus magnesium phosphate produces potassium phosphate and magnesium. Again, the only thing we can do are to put numbers in front of each element or compound. So let me list them all. All right, so potassium, I have 1 on the reactant side. I have 3 on the product side. For magnesium, I have 3 on the reactant side and only 1 on the product side. For phosphorus, phosphorus is in parentheses. The 2 outside of the parentheses distributes to everything that's inside the parentheses, and we multiply. So here we have 2 atoms of phosphorus. On the right-hand side, it's understood to be 1. And for oxygen, 4 times 2 gives me 8. And on the product side, we only have 4. I'm going to skip potassium. I can write any number underneath K, and it's not going to mess me up. And I'm also going to skip magnesium and save it for later over here, because I can put anything in that blank. It doesn't matter if it's even or odd. And I'm going to go straight to phosphorus. I have 2 phosphorus on the left, and only have 1 phosphorus on the right side of the arrow. Remember, the only thing I can do is write a number in the blank. So I can put a 2 here, and that changes phosphorus to a 2. So now my phosphorus is balanced. When I put a 2 in front of K3PO4, it changed my number of potassium. So now, remember, this 2 distributes out. So 2 times 3 is 6. So I now have 6 potassium on the right-hand side. And it also distributes to the oxygen. So 4 times 2 is 8. I'm going to change that to an 8. If we look, our oxygen is now balanced. We have 8 and 8, so we can check that. And then our potassium was 1 and 6, so we need to go change that to a 6, which makes our potassium balance as well. And so now we just need to balance our magnesium. We have 3 on the left and 1 on the right, so we can easily write in a blank here for 3. Change that to 3. And now all of our elements have balanced. The next sample problem. C5H12 plus O2 yields CO2 and H2O. Again, all we can do are write numbers in the blanks. Alright, I have 5 carbon as reactants. I have 1 carbon in a product. I have 12 hydrogen, and I have 2 hydrogen. On the left, I have 2 oxygen. On the product side, I have 2 oxygen here, plus 1 more oxygen over here, so that gives me a total of 3 oxygen on the product side. Right. So I'm just going to start with carbon. I have 5 on the left and 1 on the right. So I'm going to plug in a 5 in front of CO2, so that would change this now to a 5. And then hydrogen, I have 12 on the left and I have 2 on the right. So I have to put something in this blank that will give me a total of 12. So we would put a 6. 6 times 2 is 12. I put a 12 here. Now carbon checked off, hydrogen. Now oxygen, I have 2 on the left. Oh, I forgot to go change my oxygen number. Here I have 5 times 2 is 10, and then plus 6 more. So I have a total of 16 on the right, and I only have 2 on the left. So I need to put something in the blank for oxygen that will multiply by 2 to give me 16. So that would be 8. Change that to an 8. And now my oxygen check. So we're just going back and forth and making sure our total number of each element balance out. Make sure that they add up. Alright, our next one. Iron plus oxygen gives us Fe2O3 or iron 3 oxide. Put in our blanks. We have Fe and O. I'm going to start with oxygen because I can write any number in that blank. So I have 2 oxygen on the left, and I have 3 on the right. 1 iron and 2 iron. All right, so I need the least common multiple of 2 and 3 to balance out my oxygen. So the least common multiple would be 6. So I can put a 3 here to give me 6. And then I can put the 2 here because 2 times 3 is 6. Now that's messed up my iron on the right hand, on the product side, because I have 2 times 2 would be 4. And then on the left side I only have 1 iron, so I should put a 4 in this very first blank. Alright, so my iron's balanced, oxygen balance, done. Alright, next example. P4 So it's Br2 yields PbBr3. We have phosphorus and bromine. I have 4 phosphorus on the left and I have 1 on the right. I have 2 Br on the left and 3 Br on the right. We can put our phosphorus, we can put a 4 on this side, which gives us a total number of 4 here. And then for Br, let's change this to 12. So now we need something on the reactant side to give us a total of 12, and that would be 6. So change this now to a 12, and now it all balanced. Right, now I'll do one more example with you. Manganese plus hydroiodic acid plus hydrogen gas gives us manganese 3 iodide. So manganese, hydrogen, and iodine. We have 1 manganese and 1 hydrogen and 2 and 1 iodine on the left and 3 on the right. I'm going to skip manganese because I can put any number in this blank, and we'll go on to hydrogen. If I have 1 on the left and 2 on the right, I should put a 2, and that's hydrogen iodide. So that's balanced. And then iodine, now I have 2 on the left. I have 3 on the right. There's nothing that I can put in front of MnI3 to only give me 2 iodine. So what I'm going to do is I'm going to have to find a common multiple between 2 and 3, which would be 6. So to make this total 6, I need a 2 in front of it. And then now I have to change this so that I get a total of 6. Well, now look, that's messed up my hydrogen. So now I'm going to have to go back, and I can't check it off now. It's also messed up my manganese. Let's put a blank there. I have 2 manganese now. I have 6 hydrogen on the left. To get 6 hydrogen on the right, I'm going to have to put a 3 here, because 3 times 2 is 6. So now my hydrogen's correct. And I've got 2 manganese on the right and I only have 1 on the left, so I'm going to put a 2 here. And now that is balanced. These reactions, balancing, just takes practice. So just trial and error. Just try to sit down and work out as many problems as you can.